Hello, dear students. Welcome back to my YouTube channel. This is your Shakur sir. So, as you know that today we will be discussing lecture number second of projectile motion. In yesterday's class, we discussed about displacement in 2D, velocity in 2D. So, these things we discussed in yesterday's class. So, in today's session, we will be doing some numerical problems. Okay, and if time permits, we will be completing the new topic. One second. So let us start now. Okay, I hope my screen is very visible to you all. Done. And my voice is very audible to all of you. One second, I need to check my connectivity firstly, then I will start. Yes, screen is also visible and I am also audible. Look now, we will be starting today's lecture by doing a numerical from previous class. Okay. And the numerical is like my H max is given, that is 1000 meter. Done. So if a person throws a ball and its height is this much, maximum height is this much, how to find R max? How to find R max? If you know that from yesterday's class, what was the value of R max? What was the value of R max? R max was U square by G. Done. And what was H max? H max was U square by 2G. H max is given. I will multiply it with 2, divide it with 2. So now these things, it is given. So I can write 2 times H max. So R max is 2 times H max. Now 2. What is H max? H max is 1000. So my answer came out to be 2000 meter. Easy. So if H max is given, you can find R max. Or you can do one more thing. If let us suppose R max is given. Suppose if R max is given as 1000 meter. How to find then H max? Okay. How we will do? Sir, we know that from this expression, we know that R max is 2 times H max, right? So R max is 1000 divided by 2. I will get my H max. So H max came out to be 500 meter. So you need to manipulate your numerical so that you will get your answer. Then one more numerical. Good numerical, beta. I will write the whole language of numerical so that you will get a very better understanding of all of these things. A body is projected. A body is projected from ground. एक बॉडी को हमने ग्राउंड से फेंका है. A body is projected from ground with velocity u such that at topmost point its speed becomes half of its initial speed. Find out. First part, time period. Second part, height. Third part, range. These are the information that is given to us. We are having a body, and body is projectile from ground with velocity u and some angle theta, such that at topmost point it is velocity becomes half. We need to find out time period of this motion, h, that height of this motion, range of this motion. How we can do it? First of all, write the equation for time. What is time? Is it 2u sine theta by g? Look, 2 is constant, we know the value of 2. G is constant, we know the value of g, and u is also constant. Why? Because we just throw it with the u velocity. Now we have to find out sine theta. So to get the sine theta, the second thing is, now everything is sorted. Everything is sorted now. Let me check my screen. Okay. Okay. Look now. How to find now h? How to find now h? What is h? Sir, h is, I guess, u square sine square theta divided by 2g, or I can write u sine theta whole square by 2g. U sine theta, so u is u, sine theta is under root 3 by 2 whole square divided by 2g. I have u square into 3 divided by 4 whole divided by 2g. So my answer came out to be 4 to the 8. It is divided by 8g. This one is my answer. Okay, done. Now, third part, range. What is range? I guess range is u cos theta multiplied with t. Yes, u is u, cos theta is cos 60, cos 60 is 1 by 2, and time period is under root 3 u by g. I can write under root 3 u square by g. This is my answer. Easy? Now let us show you a one different and a very good topic to you, or a good numerical wherefrom you will get a very good understanding of a topic. That is, we have a question. I'm going to write it down. A body is projected from ground such that its range is n times of h max attained. Find out angle of projection. A very good numerical, and you will get a very good output. So I will write a box where you need to write an output. Okay, that output is very important. You need to understand that output only. If you don't know the numerical procedure, don't worry. Na? The output, that is very important to us. Tan theta 4h by r. Look now. What is range? I guess range is u cos theta multiplied with t. I can write u cos theta multiplied with 2u sin theta divided with g. I can write 2u square sin theta by cos theta by g. Done. What is h? Is h equal to u square sin square theta? So I can write sin theta divided by 2g. I can write like this now. What will be then r by h? R by h. I can write 2u square sin theta cos theta divided by g multiplied with 2g whole divided with u square sin theta cos theta. Look, sin theta, 1 sin theta cancel out, g cancel out, u square cancel out. So I have 2 to the 4, it is 4 divided by tan theta equals to r by h. Done. Tan theta, 4 by tan theta, r by h. And what is given to us? R is n times. So here is r equals to n times h. So what I can write here now? 4 divided by tan theta equals to r divided by, or I can write, okay, r is nh, right? It is nh, here is h. Cancel out. So my equals to, I can write it is 1 second. I think I had done some mistake in my problem. 1 second, beta. Tan theta. So one second. So I can write here tan theta. So tan theta equals to, it is 4h by r, and r is nh. I can write 4h divided by nh. Cancel out. So my tan theta came out to be, it is 4 by n. Theta equals to tan inverse 4 by n. This is my answer. But the thing that you need to note down, na, that is this much. So you need to write down that tan theta is equals to 4h by r. This one is important, and you need to note down only this expression. Tan theta equals to 4h by r. Okay, this value is every time valid. I will give you one numerical, na? And due to that numerical, you find how this tan theta 4h by r is important. You will, this one is very great thing, right? Output of a great thing. Just like if 45 degrees there, 90 degrees there, what will be happen with h max or r max? In the same way, you had to note down tan theta is 4h by r. If you're just making short notes, na? In short notes, keep this point. Tan theta 4h by r. And at the end of the class, or at the end of the whole chapter, I am going to give short notes in my Telegram group. These handouts also, these all handouts with my short notes. Okay, and PYQs of NEET and JEE as well. Look now. Look, beta. The numerical is like, we are projecting a particle with velocity v0. Its range is 2 times the height. Done. Find a range. Find range. Look now. What is tan theta? Is it 4h by r? Okay, 4h. What is r? Is it 2h? So my tan theta came out to be 2 by 1. Look now. If this is my triangle, right angular triangle, it is P by B. B is 1, B 2 square plus 1, 2 to the 4 or 5 root of 5. So what range 2 u square sin theta divided by r equal 2 is to the velocity is v naught square in it is under root 3 by 2, right? What will be sin theta? Sin theta. I can write sin theta. P by h. Perpendicular is cos theta. B by h. What is b? Under root of here 2 divided by root 5 multiplied by 1 divided by 5. Look now, root 5 is 5 only. So can r came out to be 4. I can write 4 here. V naught square divided by 5g. This is my number. Important. Look here. I will write now conditions for same range. Condition is for same range. Condition is for same range. Condition is for same range. So we are having 3 conditions. One condition, if we are projecting at theta or 90 minus theta from horizontal, range will be same. Second, if we are theta from horizontal and theta from vertical, range is same. Third part, so we are having it is if it is 45 degree plus theta or 45 degree minus theta, my range is same. That means, look now, 2 projections, right? One projection, second projection. If this angle is theta, if speed is same, u is same, so this one would be 90 minus theta. Second condition. If this one is at horizontal, one more. So this one will be theta from vertical, range is same. Third one. If this is 45 minus theta, so this would be 45 plus theta, range is same. You will find a very numerical direct from these points. The P by Q, direct from these points. Okay, that is conditions for same range. One more thing, if you have completed this point, now for range thing, only 3 things are there. If theta 90 minus theta or theta from horizontal, theta from vertical. Third point, 45 plus theta or 45 minus theta, range will be same in both, in three cases. Done? Now look, Facts. Fact is for same range. Fact is for same range. Suppose you fired something like this. Ranges are ranges are and angle is theta. Initial velocity and this h. Some fired one na. This height is in theta. Sorry, u same, and this angle will be 9 minus theta. Now see, what is t1? Timing for first one is it sine theta for g? What is t2? Is it 90 minus theta divided by g? Right to 2u cos theta by g. It is first one. This one is second one. Look, you in both the cases. What will be height at one? Is it u square sin theta divided by 2g? It will become u square theta divided by 2g. Now, if I multiply these two heights, h1, h2, I will sin theta multiplied with u square cos theta whole divided by 2g multiplied with 2g. Done. I can write sin theta cos theta whole divided by 2g multiplied with u square sin theta cos theta by 2g. Can I write like this now? h1, h2 becomes now it is r by 2. This is my r by 2. So therefore, I get here. One second. And multiplied with 2 to the 4, 1 by 4. So I can write here 1 h2 is equal to r square by 4 multiplied by 1 by 4. So h1 into h r square by 4 square. So h1 h2 came out to be r by. Note down this point. That means if we are throwing the body into the projectile motion, the same velocity and angles are theta, that means for the same range, so the multiplication of their height would be r by 4 square. It will be r by 4. This point is also in your short notes. You won't think this way, right? Note down these things. Now, sir, what about T1 multiplied with T2? What with multiplied with T2? So T1 is 2u sin theta by g. T2 is 2u cos theta divided by g. I can take 2 by g common. We are having care sin theta cos theta divided with g. Done. So I this term represents r. So T1 T2 equals to 2r by g. So what do you need to note down in a copy? If u is same, if r is same, and one is theta, next one is 9 theta. So h1 multiplied with h2 came out to be r by 4 square, and t1 t2 will be 2r by g. These two points you need to note down, right? Only these 2 points. Note down these 2 points now. Okay. If this thing is done now, So let us do a numerical. Let us do a numerical. Numerical is like two balls A and B are projected from ground with same speed. Ball A is projected at an angle theta from horizontal, and ball B is projected at an angle theta from vertical. Look, theta u speed is same, angle is same. One from vertical, one from horizontal. That means my range will be the same. First part, ratio of time period. Second, ratio of their heights. Third, ratio of their range. We know range will be same. It will be 1 by 1. One thing is very clear to us. Now what is time? T A, is it 2u sine theta by g for first one? What is TB? It will be 2u cos theta by g. Let us take the ratio of these two things. So cancel out, cancel out. So it came out by TA by TB is equal to tan theta. HA by HB. HA u square sine square theta divided by g divided by u square cos square theta divided by 2g. Cancel out. So my answer is tan square theta. This should be your what? Speed while you are solving something. Then okay. One more thing that you need to understand, and that is if now height 1 is equal to height, if height of the projection is same, therefore timing will be same. How, sir? Look now. What is h1? Is it u1 square, or if u differently, right? u1 square sine square 1 divided by 2g. This will be height. What is h2 now? h2, is it u2 square sine square theta 2 divided by 2g. Take the ratio of these two things. Look now, 2g cancel out. Okay, or you can do one thing. You can take 2 to cancel out. Only 2. So h1 by h2 is now square. Let us take these two things done now. So h1 and equals to, right? So it will be equals to u square sine square theta 2. So therefore I can write u1 sine theta 1 equals to u2 sine theta 2. Now do one thing. Multiply it with both and divide g both. No issue. So this will be t1, it is t2. So what is h1 equals to h2? So therefore t1 will be equals to t2. Only these things you need to note down in your copy. This was proof. You don't need to write proof. Only t1 equals to h2. You need to write t1 equals to t2. Nothing more than that. Done? So we are having now last part from oblique projection, that is equation of trajectory. So what we need to define now? Equation of trajectory. If you are done up to this point, and if you are having any comment or anything like that, you can just let me know. If not, then focus on the lecture, right? So let us discuss now equation of trajectory. Trajectory means the path on which your particle is flowing. Equation of trajectory. Equation of trajectory. Done. Trajectory simply indicates the path. Look now. So this parabolic path is known as trajectory. So you have to write the equation for that thing only. Look now. What is displacement in x? Is it u cos theta multiplied with t only? What is displacement in y, or simply y? Is it u sin theta multiplied with t minus 1/2 of gt square? Done. Now take this equation now. Y equals to u sin theta. What is time? So from this particular equation, if this is x, right? So I can write time is equals to x divided by u cos theta. Place the value in place of t. So I can write here x divided by u cos theta minus 1/2 of g. Instead of t, I will write here x square divided by u square cos square theta. Look now. Sin theta by cos theta is tan theta, and this x and u cancel out. So y equals to x tan theta. X tan theta minus 1/2 of g x square divided by u cos theta into u cos theta. We know this thing very well, right? Just multiply it with the sin theta and divide it with the sin theta. What will happen? Just note it down. So y equals to x tan theta minus, I can write here g x square. Look, sin theta cos is tan theta. So I can write here tan theta divided by, is it 2u square sin theta cos theta? Yes. Now look, this term, this thing. We know that range is equals to 2u square sin theta cos theta by g. So it is inverse of y equals to x tan theta minus x square tan theta by r. Or I can write in very simplified way that it is x tan theta 1 minus x by r. Don't write the proof. Don't write the proof. Write only this expression and this expression only. You need to write down only these two expressions. One expression, x tan theta minus x square tan theta by r, or x tan theta 1 minus x by r. Okay. Why this is very important to us? Because we are having a numericals based on these trajectory equations. Okay. So there is a possibility that the examiner might ask you these things in the coming examination. That's why we're just preparing all of these things, right? So let's start now. A numerical. Numerical is given to us equals to x, y equals to x minus 1 divided by 16x square. This is equation of trajectory. This thing is equation of trajectory, and this one is given. It is given. This thing is given to us. Okay. Done. And first of all, find angle of projection. Find angle of projection. Second one, horizontal range. We need to find angular projection and horizontal range. How we can find these two things? By comparing it. By comparing it. How we will compare it? Look, what is x? What is y basically? Is it x tan theta? Done. Minus x square tan theta by r. Now, what is given to us? Y equals to x multiplied with 1 minus x square multiplied with 1 divided by 16. So from this scenario, what you will encounter that my tan theta equals to 1. It is only possible when theta is 45 degree. And you can see my range equals to 16. That's why we need to compare these things. We can find many more things also, right? We can find now. Done. Okay, look now. First part is complete of our chapter. Now we are having horizontal. We are having horizontal projection. We are having with horizontal projection. That is, look now. If we are having a building, okay, and building's height is h, take downside motion as negative, take upside motion as positive. Now we are throwing this ball, we are throwing its velocity u. So you will find it is trajectory will be in this way. In this way. Okay. This will be it is trajectory. So same, we have to divide these two things into x direction and y direction. X direction and y direction. Why? Because 2D is nothing but summation of 1D and 1D. So we are breaking down whole thing into these two directions. So what is initial velocity of x? That is u, that is in I direction. Initial velocity of y, it is 0. Nothing in y, right? Why? Because we are throwing particle in x direction only. What is acceleration in x? 0. What is acceleration in y? That will be acceleration due to gravity, and that is downwards minus j cap. What will be final velocity in x? It will be constant always. Why? Because there is no acceleration present, so it will be always ui. What is v? V equals to u plus at. U is 0. It will be at. What is a? Ag. T is t. That means minus j cap. What is x? Distance equals to speed into time. I cap. Distance equals to ut. Ut is 0. It is 1 by 2 gt square. Gt square and in minus j cap. It is displacement, right? So what will be velocity? We know it. Sir, velocity will be vx I cap plus vy j cap. Okay, velocity. What is vx I cap? Vx is ui only. So I can write ui cap. What is vy? It will be minus gt j cap. Done. And what is it is magnitude? Sir, you can do one thing. You can write vx square plus vy square root. Okay. Let us suppose after some time your particle is at this particular point. So I will make a tangent to this particular point, a tangent to it. A tangent, if velocity is v, so one component one more component. This will be Vy, this will be Vx, this angle is alpha, suppose. So what will be my tan alpha? Tan alpha, it will be Vy divided by Vx. Vy is minus gt and it is u. Okay, done. And when you place these two values, do you know what you will get? You will get u square plus 2gh root. Look, if we are dropping something, from the height, that is motion under gravity, so my speed was under root of 2gh. If I was throwing something below with u velocity, so my value was u square plus 2gh, and that is the same one. Same one, ditto same one. Now if you want to write the displacement, done, how you will write displacement? Look now, displacement from upper end, that means this displacement, and I will write it as a s displacement. So displacement is r, or it is s, which is equals to displacement in x plus displacement in y. So I can write x, which is in I, plus y, which is in j. Done. What is x? Is it ut? Yes sir, I can write here ut I cap. What is y? It is minus 1/2 of gt square in j cap. Done. And if you want take it as magnitude, you need only x square plus y square, then you have to take out the root. Simple as it is. Nothing that much of things, right? So what you need to remember from this page, no? You can see it is somehow very large to get understand, right? Just remember these things: velocity 1, angle 1, and displacement 1. These three things you need to remember. Rest everything gets clear to you. Done. So I'm on this topic. Then we will start the new one also. Okay. Then we are left two topics related to motion. So I can do one thing now. We will do some numericals on this topic. Then tomorrow related to motion. Okay. And this Sunday most probably I will be starting something for 12th also. And in this particular winter I will be starting a couple of courses, and if you are interested you can just follow those things, right? Okay, look now, numerical. So the thing is that I will write a numerical here. Numerical is like a body is projected. A body is projected horizontally. A body is projected horizontally from top of tower with speed 30 meters per second. Then find, or let us enter timings also. Then after 2 seconds, what you need to find? Displacement vector and velocity vector. Done. What is displacement vector? That was ut I cap minus 1/2 of gt square in j cap. Done. What is u? 30. What is I? 2. Minus half of, what is G? It is 10. If you write in notation, that is I cap. What is T? It is 2 square, then J cap. It is 60 I cap minus 20 J cap. If you need this magnitude, do one thing, write 60 square plus 20 square. 66 is 36. It is 400. It is 4,000. You can write 100 into 2 square 4 into 10. So you can write it is 20 root 10 meters. Now second part, velocity vector. What is velocity vector from previous thing? Velocity vector is how much? Is it ui minus gt? Okay, I can write here it is ui cap plus gt, but that one is in minus j direction. I can write u. What is u? It is 30 I cap. I will take minus outside. It is 10 multiplied with 2. It is j cap. So my answer is 30 I cap minus 20 j cap meter per second. If you want it is magnitude, you will write 30 square plus 20 square root. This will be 900 plus 400 root 1300 root to be 10 root 13 meter per second. Easy? Easy, right? Okay. If this one is done, if you have any doubts, let me know. If not, then we will move forward with some different parameters and we will do some numericals also. Okay. Look now. Now we are having important parameter. Important parameter. Important parameters are time of flight, time of flight. Building is this much, an observer is standing here, 0, 0. Downward is minus j, upward is plus j, and height is h. I can write minus h equals to initial velocity is going down is 0. I can write 0 minus 1/2 of gt square. So h came out to be 1/2 gt square. So t is equals to 2h by g under root. Same from the gravity one. Now range, horizontal range. So horizontal range is speed that you are throwing something. No? If u cos it is u multiplied with t. So r came out to be u under root of t. T is how much? 2h by g. These two things you need to remember. Note down in your copies these two things only. Only these two things. Look, I will be showing you a numerical based on these two things. Look now. Suppose we are having a question here, where we throw something from the top of the tower here, and the height is given as 490 meters. Speed is 98 meters per second. What will be time? Simple, 2 into 490 divided by 9.8. Simplicity, right? Simplicity. 0, 0 cancel out. So t came out to be 100. It is 10 seconds. If somebody will ask you what will be range, it is u is 98 into t is 100, so my range will be 980 meters. This is how you need to write these things down, right? Important parameter, you need to just note these things. I know in this particular chapter na, kinematics and the whole mechanics. You are having lot and lot and lot of equations that you need to memorize. Okay, so nothing. When you will compare the NLM, na, you will find a lot of numericals there, right? 12th is interesting. 12th is very interesting. We're having a couple of numericals there. That is not a big deal to be to done those things, right? Now look, a very good numerical, that is, we are having two buildings. We are having two buildings. One building this much high. Okay. One building this much high. One building this much high. Okay. And the distance between these two buildings, it is given to us. It is given to us. It is 180 meters. 180 meters. This one is A building, this one is B building. We threw something from this particular point A with velocity u, done, and this should reach B. And one more thing is given to us, that is the height difference. The height difference. This height difference. This height difference is also given to us, and it is 45 meter. Find out the value of this particular thing u, so that my particle should land safely on this building. Okay, we can do one thing. We will take this thing as the origin, right? So this much is not building height. Is it 45 meter? Yes, sir. Let's suppose this one is a ground reference, right? So what is range? Is the range u into 2h by g? Okay, range is 180 meters. It is given to us. U we don't know. 2, h is 45 done, and g is 10. So 180 equals to u. 45 into 2 is 90 divided by 10. Cancel out. So I have 180 came out to be u. Here it is 3 square. Cancel out. 180 equals to u into 3. So u came out to be 180 divided by 3. So u equals to 60 meters per second. If you want your particle to safe landly on the top floor of the B, you need to throw it with the speed of 60 meters per second. You need to throw your particle with 60 meters per second. Done? Okay. Now we will do one topic, then class over. That is equation of trajectory. Equation of trajectory. Okay. This one is my building. Throwing with velocity u like this. It will go in this manner. Done. In x direction, what is my value? X equals to speed into time t. So time equals to x by u. Second one, what is y? Y is minus 1 by 2 gt square. I can write y equals to minus 1 by 2 g is g. What is t? T is x by u whole square. So I can write y came out to be minus g divided by 2u square into x square. Why? Because I will compare it with minus kx square. Equation of parabola, but negative. So it is like this. Equation of parabola. Okay, so we are done with today's topic. Now tomorrow, for tomorrow plan. Tomorrow, what we are going to discuss? Oblique projection, from height. Oblique projection from height. And sub bars. So we are throwing something in this way. B part, we will throw something in this way. Then day after tomorrow, this is third lecture. Fourth lecture will be relative motion. Then fifth last one will be rainwater or board problems. Okay, so we are having 5 days plan. This is how we will complete our syllabus. So this Friday will be last class for 2D. Then from Monday we will start NLM. I guess we are going in a very good pace, right? If extra things need to be done, so I'm going to do that extra things also. So, but I don't think extra things are being needed, right, as of now. So I hope you enjoyed this session, and if you want anything, if you want extra things from my end, you have the Telegram link below this description part. You can go there and just click on it, and you can ask me your doubts and your issue things, right? Else you can just comment below, and I will just see these comments regularly if you want anything. And I guess thank you for today's session. Thank you, madam. Thank you very much. Bye.